Okay. For example 7, it says above that, it says for trigonometric equations containing more than one trig function, sometimes we can set one side equal to 0 and factor the other side to separate factors that contain the different trig functions. Okay? So on number 42, even if this problem would have started out as 4 sine squared cotangent x equals 3 cotangent x, since I recognize we've got a mixture here, I forgot to write my x right here, didn't I? Since we've got a mixture here of sines and cotangents, the first step we'd want to do is get everything on one side. So I would subtract 3 cotangent x from both sides, and then I would arrive at what we have here on number 42. Now, if you look at this, now we can see that we've got a common factor in there. We've got a common factor of cotangent here and here. And so what we're going to do is factor out that greatest common factor, pull it out front, and write the leftovers. Okay? I'm pulling out a cotangent x, so leftover is 4 sine squared x and also a minus 3. Bring down that equals 0. Now you can check this by making sure, at least visually, at least mentally, when you distribute the cotangent x back through, you end up with what we started with. So yeah, I think we factored that out correctly. Now, what we have is a factor, if you want to put that in parentheses, a factor times a factor equals 0. So again, we set each factor equal to 0. So cotangent x equals 0, and 4 times sine squared x minus 3 equals 0. And now we'll concentrate on solving each of those two equations. Okay? Over here on the left equation, solve for x by taking inverse cotangent of both sides. Okay? And so what all angles have, well, at least what all angles in the interval from 0 to 2 pi have a cotangent of 0. Let's see. Another way to think about that, the cotangent of what angles are equal to 0 is going to be the cosine of what angles divided by the sine of what angles equals 0, right? Because cotangent is cosine over sine. So anytime cosine is 0, cotangent is also going to be 0. So, for example, I'm thinking pi over 2 and 3 pi over 2. Those are going to be the places where cosine is 0, and also cotangent will be 0. These are also the places where tangent is undefined. Cotangent is 0. So there's 2 answers so far. Let's look over at this other equation. First of all, we better solve for sine squared x. Add 3 to both sides first. We'll have 4 sine squared x equals 3. Divide both sides by 4. So we will have sine squared x equals 3/4. Now we're ready to solve for sine x by taking the square root of both sides. And when we do that, don't forget the plus or minus. So we have sine of x equals, right, because the square and the square root knock each other out, just leaving us with sine x equals both positive and negative. Square root of 3/4 is the same thing as square root of 3 over square root of 4, which that will simplify to be square root of 3 over the square root of 4 is just 2. So I think once again, Since we actually have two different equations, probably what we're going to want to do is break this apart into two equations. One is going to be sine x equals positive square root of 3 over 2. The other one is going to be sine x equals the negative square root of 3 over 2. Okay, over here on the left side, to solve for x, take the inverse sine of both sides. All right, and now we need to think, what all angles have a sine value of positive square root of 3 over 2? Well, we know sine is going to be positive in quadrants 1 and 2. So the angle that has a sine value of square root of 3 over 2 is pi over 3, right? 60 degrees. Yeah, that's how that works out for my fingers. And in quadrant 2, the one that has a reference angle of pi over 3 is going to be 2 pi over 3. All right, there's an answer. There's an answer. Over here on this right-hand side, again, solving for x, take the inverse sine of both sides. So now we're looking for the angles that have a sine value of negative square root of 3 over 2. Sine is going to be negative in quadrants 3 and 4. Truth? Okay. Now, it's going to have the same reference angle of pi over 3, but the angle that has a sine value of negative square root of 3 over 2 in quadrant 3 is going to be the 4 pi over 3. And then in quadrant 4, the angle that has a sine value of negative square root of 3 over 2 is a 5 pi over 3. Okay? So let's put all of our answers together. We actually have 6 answers here. And we probably want to put these in order, all of these in order. Here's going to be my solution set. This is where I actually have room to write everything. Okay, the very smallest is pi over 3. Got it. Next, we would, in one rotation, or counting these off in numerical or ascending order from 0 to 2 pi. Next, we would hit pi over 2, 90 degrees. Next would be this angle in quadrant 2, 2 pi over 3. Let's see. Then next, we would hit this angle in quadrant 3 of 4 pi over 3. That's in quadrant 3. Then we would hit this quadrantal angle of 3 pi over 2. And then finally, we would hit this biggest number, this biggest angle of 5 pi over 3. And that would be in quadrant 4. So there's our solution set for all the solutions to our equation, but just for one revolution. Okay? That's what they asked us to do in the problem on that interval from 0 to 2 pi. And all these angles lie in between 0 and 2 pi.